I guess everyone first. I guess we'll start by going over like what uh, to expect from these types of problems. So basically, we have. So hopefully, you guys have created the account, or at least like can create the account because you'll need an account for this. So then, so you can view all past contests in the contest section here. You basically split up by the contest. So 2019 December, 2019 February, for example, these are contests. Each contest has, okay, each contest has basically 4 divisions, except for the earlier ones, which have 3 divisions. For now, the problems we'll do are the ones from the contest with 4 divisions because the difficulties match more closely. So, yeah, there's 4 divisions. Everyone starts in bronze. So I guess let's start with this problem. It's a relatively basic bronze problem. So basically, in general, they have this information, like this kind of cow-related story thing, except not really a story. And there's a lot of useless information. Like Farmer John has decided to update his farm to simplify his geometry, and all the way up to here. You can, I guess, graze through information that looks kind of like story-like. So like this paragraph in this problem is like it. I guess it can kind of give you an idea of what the problem is, but it's not necessary to like read this line by line, especially in problems where these descriptions are like really long, because you'll just be wasting time. However, in like the basic like information you'll need. So here, this is the problem. I guess there's some problems where like there's a lot more of this information, so then it'll help more to know what to look at so that you won't get overwhelmed by the amount of information. So here it's please help Farmer John. Farmer John is not important. Please figure out the minimum area needed to make a square pasture so that if placed appropriately, it can still cover all the area formerly covered by 2 rectangular pastures. So you basically have a general idea now. It's 2 rectangles. We have 2 rectangles, and we want a square of minimum area that covers both rectangles. So yeah. And then the input format and output format is usually always important because that's where you'll find the majority of the information. In fact, sometimes you can literally get the problem from the input format and output format, but like you should probably just read like the background information of the not the background information, the problem information, but the story background story information stuff is not really needed that much. So then the input format tells you basically how the input is going to look like, and you can match like the input format with the sample input, which is one sample of the input. So in this example, there's just going to be 4 integers, x1, y1, x2, y2 in the first line, each in the range 0 to 10, so like this. And then guaranteed that x2 greater than x1 and y2 greater than y1. So basically lower left corner and top right corner of a rectangle. And the second line is similar, lower left corner and top right corner of the rectangle. And there's no intersections, they specify that. So then basically there's also the output format, and the output, you need to know what to output, obviously, because that's what will be graded. And you also need to know what to input because obviously you can't get the output without reading the input properly. So then an output consists of 1 line containing the minimum area required of a square pasture that would cover all the regions originally enclosed by the 2 rectangular pastures. So it's just a single number, an area. And basically we've gotten the basic information of the problem. We're given the coordinates of basically the bottom left and top right corners of two rectangles that don't overlap, and they're all integers, so we don't have to worry about like floating point decimal stuff. And then they won't intersect though. Yeah, and then we're trying to find the minimum area of a square that covers all the regions. And there will usually be some explanation of the sample output, so that if you're actually confused about the sample output, or like why is it this, maybe you misread the problem, then you can read the explanation and see, and sometimes you might get some information that makes you realize that you misread the problem. And another thing is, like, these explanations can also be like useful for making sure you didn't misread the problem. Like maybe the sample output's still the same, but then like, or like you just like, you know, misread the problem somehow still. That's a possibility, although it's rare. So this thing, like, you should at least kind of read over it to make sure that you got the proper problem. However, the way they get the answer in the sample problem is not necessarily how you'll program your basically the thing, because this is just fundamentally how you would do this by hand, not how you would do it by a program. Okay, so any questions about this stuff so far? Okay then, so again, to do these problems, in bronze, maybe it's not necessary, although some problems it may still be necessary for some of you, or for, depending on the problem. You should like plan out what you want to do, especially in higher divisions. You 100% need to, starting from like silver and even harder bronze problems, like you definitely need to have a kind of like plan, preferably actually also on paper, so like not just you look at the problem and go straight to programming, because that way you'll have an idea. And sometimes you catch like you get an idea, and then all of a sudden when you work it out on paper, you realize that the idea doesn't really work. And the sample test case is a really useful way of like, you try your plan on the sample test case and see how it would work, or like how you would do this. So in this case, we have basically two rectangles. I mean, your drawing doesn't have to be the best. Obviously I'm drawing on the computer, so it's gonna be slightly worse, but anyway. So basically what we have is two rectangles, and how would we make a square that covers both regions? Well, obviously the square can't be like, it has to at least be this long, right? Because otherwise how would it cover both of these two rectangles, right? So it has to be at least this long, and then has to be at least this tall or wide, however you look at it, because, well, again, it's the square is not going to be able to cover these two rectangles at the same time if it's shorter than this, right? So then we have something like this. And since it's a square, obviously the longer side is what matters. So the shorter side, like, you can't have a square that's this big, because then it's not going to be long enough. Meanwhile, if you have a square that's this long, it's also going to be wider than this. And since we don't really need we don't really need where the square is, we basically just need the dimensions, or rather just the side length of the square, and then we multiply that by itself to get the answer. So in this case, the answer would kind of just be the maximum of the desired length, needed length, and needed width that's basically what the answer is going to be, the maximum of the needed length and needed width. And needed length equals max x coordinate minus max, min x coordinate, as shown also in this picture, which might also help, basically. And then similarly, the needed width equals max y coordinate minus min y coordinate. So any questions about this logic? Okay, so then to program this, we just first find the max x coordinate and the min x coordinate and the max y coordinate, min y coordinate. And then we calculate the needed length and needed width and take the maximum of them. And then that would be it. So then basically, if we were to program this, I guess I'll just do it for this one. It's not that complicated. This is one of the simpler problems. So hopefully you guys at least followed along with the logic. So right here, there shouldn't be any restrictions on what you name your file or some stuff like that. I'll just call this actually, I'll just call this P1 for now. So there's one thing about the USACO that like changed, which is that back then they required file input and output, and now they don't require file input and output. So now you don't need to do file input and output. However, if you want to like submit to the previous contest problems, you still need file input and output. So yeah. So I'll do system input and output for now. So
Quick question, what does the input next dot next int mean?
that's just taking the next integer in the input.
Oh, okay.
And then we just do here. Of course, this code could be simplified like a bit, but I'll just do the conceptually simplest. So max x equals maximum of ax2 and bx2. Wait, well in Java we do math.max. And max y, first min x, math.min AX1, BX1. Remember that AX1 is less than AX2 here. X1 is less than X2 in the input, and Y1 is less than Y2. So then and we get something like this. And there we go. So now when we run this with the sample input,
Don't you have to square it?
Forgot to square it. So int s equals that. And it's probably a good idea to test at least the sample input locally before you go like actually in the contest and submit it, because although there's unlimited submissions, the thing is it takes a while to grade, and like that it's just a waste of time if you get a compilation error or like fail on the first test case or something. So the first test case will always be the sample test case, and if you fail on that, you fail the problem, and you have to at least get this past the sample test case to do the later test cases. So each test case is basically a different set of data. So now run the sample test case and we get the right answer. So now back in the problem, make sure you choose the right language. It's no big deal if you like accidentally submit something like bad, but like it's just a waste of time, because sometimes it'll take a short while before you even notice. And then it'll take a while. And oh wait, oh yeah, I forgot. Need file input and output for the. So nowadays, like we don't need file input and output, but for the past problems, we still do need the file input and output. So for this, I can just do something like so this was what I used to do with like file input and output, like because it's much more convenient to test using system input and output, although now it's not really necessary. So let me try that again now that I've actually got the file input and output. Empty output. Okay, wait. Hold on, I forgot to. Okay, yeah, this was much more annoying back then. Now you can just do system.out.println. But anyway. Okay, there. And basically the green with the asterisk means correct. And this thing is done on, like grading is done on the test case by test case basis. So if you get a single test case wrong in a 10 test case problem, you get 90% of the credit. If you only get the first test case, then you get like 10% of the credit in a 10 test case problem. Sometimes there's more than 10 test cases, but like each test case is weighted equally. So in a contest, like there's a total of 1,000 points, and basically each problem, there's usually 3, haven't seen 4 or something like that in a long time. So basically you could treat it as if there's 3 problems in 4 hours. Each problem is weighted equally. So obviously do the one that, like, if one of them is easy, you just do it. It's because they're weighted equally. So it doesn't make sense to save the easier ones later. So then each test case is also weighted equally. So just because you feel like a solution doesn't work doesn't mean you shouldn't submit anything. If you can even get past the sample test case with, say, a brute force solution, even though brute force doesn't normally work, you'll get the first test case worth of credit, basically. Okay, so yeah, don't not try a problem. If you don't try a problem, chances are you're not getting promoted, or at least very low chances of not getting promoted, like very low chances of getting promoted, especially in these lower levels. Like you have to, at least, like if you are stuck on a problem for some reason, at least submit something that works. Of course, if you fail the first test case, then you're not getting any credit. But other than that, we're good. So any questions about this stuff in general? Okay, then, so yeah. By the way, a bunch of types of output is, well, first there's the either compilation error or failed the first test case. We saw that big red box earlier. That's what that looks like. Basically, a wrong answer would be red with an X, timeout would be red with a T, and any other error is like, there could be E or like M or like exclamation mark. Exclamation mark is runtime error. So anything that's red is incorrect, but you can get extra information. Like if it's wrong answer, you'll know that something is wrong. Actually, wrong answer is often a very bad thing. If it's runtime error, you'll know that there's somehow a runtime error somewhere in your program, and you'll know to look for what can potentially cause like an exception or something like that. Okay. So I guess now that we've gone over a problem, try reading over this problem for like 3 minutes and just putting in chat or something the minimal information of the problem that you actually need. So what you have to do and like what there is and what you have to output, or like what you have to do in the problem. Okay, starting now. Also try to like think about like how you would do this problem. This is another one of the relatively easier ones. So hopefully like some of you can just like know how to do it. So yeah, in chat. Okay, so I guess a bunch of you got it's basically just we have two intervals. The intervals are like from integers to integers, so we don't have to worry about like floating point stuff. Usually USACO, it's just integers to because their purpose is not to test you on floating point stuff. Their purpose is more to test you on like algorithmic thinking, programming, stuff like that. So basically we have two intervals and we're trying to find the length of their union, right? They could potentially overlap or not overlap. Right, so basically, how would we do this? Well, we note that overlap if the intervals, so if intervals don't overlap, result is the sum of lengths of intervals. And if the intervals overlap, then the result is the largest x minus the smallest x. So for example, 4, 8, and 7, 10, they overlap, so it's just basically 4 to 10. Because 4 to 8 and 7 to 10, I mean, it paints 7, 8 twice, but we don't care about that. Like 4 to 8 and 6 to 10 would be the same result, right? So if they overlap, if they overlap, you note that they're basically a single interval now. So therefore, you just take the larger end minus the smaller end. And if they don't overlap, it's two separate intervals. So again, you take the sum of the larger end minus smaller end, like quantities. So if it was like 4, 6, and 7, 10, we would take 6 minus 4 and 10 minus 7. But here we don't do that because that would count 7 and 8 twice. So all we have to do is split it into two cases and then we're okay, right? Any questions? Okay then, so I guess try to program this for like, say 7 minutes or so. Just to in general, a problem, you may think you get it, but like you actually don't get it. You realize like when you start programming, although maybe not this problem, but like get into a habit of being able to program the problem rather than just think about the problem. Because a lot of times what you think might be incorrect, and even if what you think is correct, there might be some details that you may have missed or like you just is a bit harder than you think. So when practicing, you should probably like do the whole, like actually program the problem rather than just go through the thinking and thinking that you can program the problem. Just a good practice. And a lot of the time, you can figure out that you didn't get that, like didn't actually the method doesn't work or you don't know how to implement it while you're programming. You like before you even submit. Sometimes you get like you submit and it's a wrong answer. So yeah, there's both of those types. And if you have any questions like right now, you can like, I guess, either chat or like just say it out loud. Or if you like didn't get the problem or something, in case that happens, like from now on, not just this problem. Okay, so I guess 7 minutes are up. Everyone, like don't worry if you're not done. 7 minutes might not be enough. You have like 4 hours for 3 problems after all. Even an easier problem, you should have like a good half an hour. So everyone just in chat put 1 if you're done, 2 if you're like almost done, 3 if you're just still doing it but you're not stuck, 4 if you're stuck, and 5 if you just have no clue. Answers are anonymous, so like don't worry about telling the truth or stuff. Oh yeah, if you answered 4 or like tried to say what you're stuck on, like for example, you don't know how to say if the intervals overlap or not, you're stuck on file input output, you're stuck on something, like what type of stuck? Yeah, everyone who answered 4, what, like, how stuck are you? Like, what are you stuck on? Everyone who answered 4, like, at least like say like, are you stuck in general, or like are you like stuck on a specific aspect? Oh yeah, another thing. Okay, how about this? Everyone, put A if you understand how like my logic for solving this problem works. B if you have questions, and C if you just don't get it. Okay, so mostly A's. All right, so one question that I can answer. So why does overlapping actually matter? So overlapping matters because basically if the intervals overlap, sum of lengths will double count overlap, because the problem statement doesn't want us to double count the overlap, right? But if we like don't like, yeah. Okay, so everyone gets why like overlapping matters now. If the intervals overlap and we just take the sum of the lengths, we'll double count the overlapped portion, right? Like 4, 8, 7, 10, we'll double count the 7 to 8 portion. Here, 4, 8, and 7, 10, it's just 4 to 10, like doing it by hand. But if we do the sum of the lengths, that's 4, that's 3, that's 7. So total 7, and that's not right because we're double counting 7 to 8. So then I guess now your question is, how do you check for overlap, right? So the way you check for overlap, there's like two different, like, I guess, fundamental strategies. One, simplify the problem by first sorting the interval, like reordering. I mean, you can barely call this sorting, but reordering the intervals if they are not in order. So that's one way you can do this, right? So if you simplify the problem by just first reordering the intervals if they're not in order, so by in order, like, let's just compare the first coordinate, for example. If A is greater than C, then I swap the intervals. Like, hopefully everyone knows how to swap variables, right? Like, basically, swap interval would be like something like this. So that would be one way. So I perform this right here. If A is greater than C. What? What? So something like this. So once we do that, now we can ensure that A is less than C, basically. And then we'll be good for like, we don't have to deal with special cases and stuff like that. And then afterwards, we can do something like, for example, if B is greater than C, so here it would be reordered. So 4, 8, then 7, 10, 8 is greater than 7. That means it's overlapped. And then else not overlap. Right. So that's one way to do this. So any questions about this? So yeah, that's one skill you can like get from this, because sometimes it's not just 2 intervals. Sometimes it can be like up to 100 intervals. Sometimes just sorting them either by first or last value can help. Or even if it doesn't help, it conceptually just like, you might feel better if they're sorted. So every time the input's out of order, you realize that like you can sort it if like you worry about it being out of order. So any questions about this approach? And the second way, just cover all cases. So for example, if B less than C or D less than A, not overlap, and then else overlap. So I guess it might be a bit less obvious why, but if you think about it, these are 2 intervals, right? If B is less than C, and well, we know C is also less than D, A is less than B, less than C, less than D, they're not overlapping. The other case where they're not overlapping is when C less than D, less than A, less than B, which is covered in this case. And no other cases are not overlap. Everything else is overlap, right? So basically we have this. So any questions about this? Sometimes just cover all cases can get more complicated. Sometimes it's simpler. In this case, it's simpler if you can like think about it. Right? But you can just do whatever is simpler for you or whatever comes to mind first, as long as it's not too big of a difference. So now I guess I'll just go over this then. So just do a new one. And you can see that once we've gone over like how to do it, programming it, as long as we've got the right idea, programming it should be at least easier than doing it. The problem with programming is if the idea doesn't work in general, or if there's a detail that you missed that is hard to program. So then this one just and here, if you like reordered them, you might not have to do like this type of stuff, but I didn't reorder them, so I'm just doing this. And then now when I run it with the sample input, it should work 6. I tried running it with something else, 3, 6, 8, 10, so non-overlapping, 5. So yeah, usually you can do like create your own test cases like that, like at least the most basic ones, just to make sure that you're not doing things completely wrong. Because once you submit it up there, other than the first test case, you don't know what you got wrong. But if you can somehow find a mistake on your own test case, it'll be easier to find what you got wrong because you have the test case where you got wrong. In the submission, you don't have that. So then I submit the file. Oh, wait, hold on. I need to first turn on the file input and output. So yeah, it's gonna give that big red box thing. Now it should be good. So in the actual contest, you won't need to do the file input and output because they got rid of that. But past contests, you'll still need that. And yeah, there we go. So any questions? Okay, so does this still work if one interval is contained within the other? So for example, we have 4, 8, and 5, 7, right? Well, in this case, it still works because like, or in general, you can see that it still does work because we take the maximum 8 and 7, we take the minimum of 5 and 4, and we get 8 minus 4. And in general, if one interval is contained, if one is contained in another, then it is just, we have one of the intervals is useless, right? So for example, 4, 8, and 5, 7, 5, 7 is just useless. And our code for maximum of right endpoint minus minimum of left endpoint takes care of this like case. So yeah, good thinking. Should always think about all cases. Like at least like, I mean, if you can. So like there might like even I can like miss a case in some problems, like, and it'll be like pretty hard to do. But if you consider all cases right from the beginning, then it might save you a lot of debugging, because sometimes it might like the wrong answer might not actually be fundamentally like a problem in your code. It's just an edge case. So yeah, good. So this does work if one interval is contained within the other. I guess, I mean, you could see it from all of these test cases being right, but anyway. Yeah. In terms of the thinking, it works. So, yeah. And in actual contest, like if you get all the test cases, chances are just you don't have to look at the problem again. But in practice, you might want to think about this. So, any other questions? Okay, then. So I guess we can do a slightly more complicated one then. So right here, this one. So I guess first take like 4 minutes to read the problem and get the fundamental information from the problem and put it in the chat. So after you come up with the solution, like no, what the problem essentially you want to do, then I'll go over the problem, like at least the problem statement. And if you can also say like your idea on how to do the problem in general. All in chat. So yeah. Okay, yeah. So for reading how you read these integers, basically you first read this and then use a for loop or something to read the rest of them. And while you're reading them, also store it in an array of some sort so that you can access it later. Okay, so I'll go over this, at least the general idea of what we're supposed to do. So basically, again, we have, so in preparation of the upcoming fall tournament, whatever, there's n cows, so 1 less than or equal to n less than or equal to 100. That in the later on in like silver or something, this is going to be like important information, because if n is too big, sometimes certain solutions may like time out or stuff. But in bronze, usually that won't happen. For this problem, at the very least, that won't be a problem for most solutions. So the cows are standing in a long line with each cow I standing xi units away from the barn. So basically, we have an integer n. The second line contains n space separated integers. So basically, we have n space separated integers. So 5 integers to here, each representing the location of the cow. So here, like cow 1 is at location 7, cow 2 is at location 1, cow 3 is at location 3, cow 4 is at location 11, cow 5 is at location 4. And these are on a number line, so one-dimensional. And now, one thing right from the beginning that will be really helpful is just literally sort the array. Because it doesn't matter whether cow 1 is at position 7 and cow 2 is at position 1, or rather whether cow 1 is at position 1, cow 2 is at position 7. That just doesn't matter. What matters is that we have a cow at position 1 and a cow at position 7, right? So if we sort the array, we're losing 0 information here. So at least for this problem, make sure that like it works for the problem. But for this problem, the first thing to note is sorting will like not affect the answer, right? And makes the solution much easier. Okay, so that's the first thing. So something like arrays.sort ARR if ARR is the array used to store the integers, right? So that's the first thing. Always think about like, if we get like this list of integers, think about whether sorting will affect the problem or not. Sometimes it actually does affect the problem. So you should think about whether it does. And also think about whether it helps with the problem or at least makes it simpler, because sometimes it's just very unnecessary. So we have these bunch of locations. So basically now the sample test case is equivalent to 5, 1, 3, 4, 7, 11. Doesn't matter like if it's this or that, because the locations of cows overall are the same. It's just different cows at different places. That doesn't matter, because the cow index in this case doesn't actually matter. So what's the problem say? Problem says that when cow I receives a ball, either from Farmer John or from another cow, she will pass the ball to the cow nearest her. So 1 will pass to 3, 3 will pass to 4, 4 will pass to 3, 3 will pass to 4, and so on. 7 will pass to 4, and 11 will pass to 7. Right. So then, yeah, we have that. So next, we have, so that all the cows get at least a little bit of practice, Farmer John wants to make sure that every cow will hold the ball at least once. So basically, for example, we need to pass a ball to 1 because no one's passing a ball to 1. So that's an observation. For example, 11 again, 11's far away from 7. Like, so if we don't pass a ball to 11, the ball's never going to reach 11. And we need to figure out the minimum number of balls. So again, of course, you should know what you're trying to find out. The minimum number of balls he needs to distribute initially to ensure that this can happen, assuming he hands the balls to appropriate initial set of counts. Okay, so basically, yeah. And I'll just write that write this down as well. 1 passes to 3, 3 to 4, 4 to 3, 7 to 4, 11 to 7. Okay, so yeah. So now we have like a lot of times you just need to think about like how you would like do this. And a lot of times in these types of x coordinate things, you first look at the edges. So for example, 11 definitely needs to have a ball at some point, right? Because every count needs to have a ball at some point. So how will 11 get the ball? There's 2 possible ways. One is we just directly pass it to 11 from the beginning, and 2 is that some other cow passes it to 11. However, we notice that 11, like no other cow passes to 11. So then we realize that basically whenever nobody passes to a cow, we always need to have the cow initially. We always need to initially give the cow a ball. Okay, so any questions about that logic? Whenever nobody passes to a cow, well, the cow needs to get the ball at some point, so we just give it at the beginning, because that's the only way. Because there's only 2 ways to pass, like give a ball to a cow. It's passing from cow to cow, or right from the beginning, the cow just has the ball. And yeah, why does nobody pass to 11? Because 7 passes to 4. 4 is closer to 7. Like 7 is the closest to 11, but 11 is not the closest to 7. Right? It's not symmetric because 4 is the closest to 7. Any other questions? Okay, so then the remaining question is whether passing to cows that don't get anything, like whether we doing that actually does stuff, right? Whether that's actually going to work. So we pass to, in the sample case, we pass to 1, we pass to 11, because those 2 are the ones where no one's going to pass to them. 11 goes to 7, goes to 4, and 1 goes to 3, goes to 4. Everyone's passed there. That doesn't necessarily mean it actually works. Now, here's one specific edge case where this isn't going to work. 2 and then say 3, 4. Here, 3 passes to 4 and 4 passes to 3. So no one has a nobody passes to a cow. However, we need to give the ball to one of them because that's obvious, right? You can't have no ball, it turn into a ball. So here, we need to watch out for this type of case. Okay, so, and in general, how do we prove that this case and nobody passes to a cow are the only cases? Well, what are the other possibilities? There's cycles, so basically, so we have A goes to B, B goes to A, and then nobody passes to A, B other than A and B. So that's basically the general reason why this edge case is different. Is it possible for something else like that to happen? A to B, B to C, C to A. Well, that's not possible because how is this supposed to happen? If we order them A, B, C, that's not going to work because A passes to B, B passes to C, C is not going to pass to A, it's going to pass to B, right? So nope, A, C, B, well, A wouldn't pass to B then. B, A, C, A passes to B, B would not pass to C. B, C, A, like get the point, right? Basically, this type of cycle is not possible. So we don't have an isolated cycle type thing, right? So therefore, assuming there's none of this type of stuff for now, when we have a cow where someone else passes to them, we don't have to pass to that cow directly. We can just go backwards, like to that cow. So we only have to look at whenever nobody passes to a cow. We obviously need to pass to them. So then the general idea would just be this. Whenever nobody passes to a cow, we give the cow the ball. And then afterwards, we obviously check which cows like the ball gets passed to so that we can get new information. And then, yeah, so then afterwards, we're good. And then we take care of this case where A goes to B, B goes to A, nobody passes to A and B. And other than that case, we're good. And since we've conveniently sorted our array into 1, 3, 4, 7, 11, A goes to B, B goes to A, it's always adjacent elements. So 1, 3, is that the case? No. 3, 4, I mean, A goes to B, B goes to A, but 1 goes to 3. So we don't have to worry about that. And then 4, 7, it's not such a pair because 4 goes to 3. 7, 11, yeah. And there is the case where there's just one cow. We obviously have to pass no, that falls under the category of nobody passes to the cow, right? If there's just one cow, no one's passing to that cow, right? So any other questions? Okay, so now the question is, how would we check nobody passes to the cow, right? Because that's an important question. So it's not that obvious. However, we can just do sequentially go through everything. The sequentially go through everything strategy. So sequentially go through everything. You could call this sequential search, sequential processing, whatever you want to call it. Sequentially go through everything and check what the cow passes to. So in this case, 1 passes to 3, 3 passes to 4, 4 passes to 3, 7 passes to 4, 11 passes to 7. So 3, 4, 3, 4, and 7 do not fall into this category, while 1 and 11 are not part of 3, 4, 3, 4, 7. So then we have to do that. And in general, we can just use Boolean array to check, like to keep track. So basically, for example, false, 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 false. 1 passes to 3, so true. 3 passes to 4, true. 4 passes to 3, well, this thing's already true. 7 passes to 4, already true. 11 passes to 7, so true. And then 1 and 11 are the remaining ones, right? So any questions about that? Okay, so everyone, I guess, in chat, put A if you understand the idea, B equals like have questions, and C is don't understand the idea. Okay, so everyone has A. Okay, then. So then we're kind of running out of time, so I can't let you like program yourself. I guess, I mean, since there's going to be more problems for you to practice, so I guess I'll just go over this just because this is the first problem we've had that was this, that was of this difficulty, you know, like the first two were easier than this. So I guess I'll go over this. So right now I'll like take a screenshot if you need that or something, like if you want, and I'll clear the share, like the what I wrote here. Okay. So now I guess let's go to our here. So just proof file. Okay, so again, for how do we read the input, we do int n equals input dot next int. Then we use a loop. And how do we keep track of everything? Well, we basically just use an array. So also another thing, in all USACO contests, it's probably a good idea to just import java.util.star, because that way you won't have to worry about importing it while you're in the middle of your thought process and program, because that's less efficient than just including it right from the start. Import java.io, I mean, you should include it if you're doing the old problems with the file input and output. So then we just have something like this. So something like that. So that's reading the input. And then now sorting the input. Again, you should sort the input if number one, sorting doesn't delete information or stuff. Like sorting doesn't affect the problem, and two, it simplifies the problem. And in this case, it does simplify the problem. So next, remember we had to keep track of. So remember, we want to count number of cows that nobody passes to, plus number of pairs that nobody else passes to. So now we can do the following. So passes to, and receives, okay, passes to, so stores what each cow passes to, and Boolean meatball, I guess. Stores cows that nobody passes to. So yeah. So again, don't be afraid to use arrays or stuff to store information that you need. So then next, what we do is just sequentially go through everything. So one advantage that we have is from sorting is that now we only have to check the left and right. So at cow I can only pass to cow I minus 1 and cow I plus 1, because, or cow I plus 1, because those two are the only possible ones that are the closest. So now if I is 0 passes to I equals 1, if I is 1 passes to I equals 0, not I is n minus 1 passes to I equals n minus 2. And otherwise, we just do if passes to if like locations are met, I minus locations I minus 1 is less than or equal to locations, because ties, after ties, the cow hands to the, if multiple cows are the same distance from like a cow, she will pass the ball to the cow farthest to the left among these. So tiebreakers be passed to the left. So if the distance to the left is less than or equal to the distance to the right, then basically we do something like passes to I equals I minus 1, and then otherwise passes to I equals I plus 1. And actually, just to keep it consistent, we can do this. Okay, so that's the passes to, and now need ball up. Oh, wait. Okay, don't need ball. Stores cows that someone passes to, somebody passes to. That's probably better because by default, int arrays are 0, Boolean arrays are false. So if we just initially store cows that somebody passes to, so initially they're all false, but then once we find that cow A passes to cow B, then don't need ball of B is false. Equals, like, don't need ball is true, I know. So if A passes to B, then B don't need to give B ball, excluding this edge case that we're dealing with later. Okay, so right there, now we've dealt with count number of cows that pass to, like, that nobody passes to. Everything's stored in this array. We just count the number of falses. And then next we need, so let's actually just store our result right now. So int result equals 0. If don't need ball. So if there needs a ball, then result plus plus. And now we can take care of pairs that nobody passes to. Because remember that these pairs must be adjacent. We sorted the locations already. So we just have to go through this. So we just need to go through all n-1 pairs. So from 0, 1 all the way up to n-2, n-1. So first of all, we need to check A passes to B and the B passes to A. So basically, if passes to I equals passes to, so assume like A is I, B is I plus 1. If passes to I equals passes to I plus 1 and passes to I plus 1 equals passes to I then we have to check. So maybe I should put that there. So then we should check.
Oh, don't you mean like passes to I equals like I plus 1, not passes to I plus
Oh,
1?
wait. Yeah. Okay. Yeah. Good point. Yeah, that's what I meant. Okay. So yeah, passes to I equals I plus 1 and passes to I plus 1 equals I. Yeah. So yeah. So this type of problem, generally, like when you go through the sample test case, you'll see like that's a problem, but it's better to catch it while you're programming, I guess. Nice catch. So check nobody else passes to A and nobody else passes to B. So how do we do that? Well, who can pass to A? Well, only I plus 1 and I minus 1 can pass to I. So we only have to check the left and right. And in this case, for I, we only have to check I minus 1 because I plus 1 is not into consideration. And for I plus 1, we just need to check I plus 2. So basically, first, if I minus 1 is less than 0, that means that no one else can pass to the beginning. Or I minus, no, or passes to I minus 1 not equal to I. Then this means check nobody else passes to A. And then we also check nobody else passes to B. So and either I plus 2 is greater than or equal to N, which means I plus 1 is the end. It's N minus 1, which means no one else can pass to it. Or passes to I plus 2 is not equal to I plus 1. And in general, I have a habit of like just keeping these parentheses, like putting these parentheses, even if like and or have different orders of operation, because it's just much more clear when we do this. And you don't have to put it on different lines if you don't want to. I just did that because I'm running out of space. So then afterwards, if this is true, then, well, we have such a pair, so result plus plus, right? And then we print result. And then we run with our, wait, hold on. We run with our sample input and we get 2. That's good. We can make sure our nobody, like the pairs thing works by testing out, like say this. So 8, 1, 2, 4, 5, 7, 8, 10, 11, something like that. It should be 4. And yeah, that's 4. So now that we've tested some basic cases, maybe mix them. So like say 7, 7, 1, 3, 11, 4, and then add some random pair 60, 67 out there. And it should just be 3, one more than the original. So yeah, 3. So now that we've tested it on our basic test cases that we made, we can just submit it. If it's a past problem, like, well, you should look at like the problem should tell like whether like it's here, like goofball.in, for example. More recent contests, you can see like right here, it's like system.in. It's just gonna say, so depending on the problem you do. So then I do this, I choose the file, P3, submit the solution. And then we should get the results. Hopefully it's good. And it's good. So yeah. Any questions about this problem?
I joined late. Could you explain it a bit, please? Sorry.
Like the whole problem, or like, I mean, we're kind of like.
Oh yeah. Okay, can you put the code in the chat then, so I can take a look at it?
Okay, wait, hold on. The code is pretty long. That might not work in the chat. Okay, I'll show the code. I don't think I can put the code in the chat. I can put the code in the Canvas thing once the thing is done. So yeah, all of this code will be available in the Canvas thing by sometime tonight. Also the homework problems by sometime tonight. So yeah.
Okay, thank you.
If you arrive late, you can just get this stuff on the Canvas. So any other questions? All right, so explain cycles. So the problems basically we had were either nobody passes to a cow, or we have a group, an isolated group of cows that only pass to each other, right? These are the two possibilities where we need a ball. Either nobody passes to the cow, or an isolated group of cows that only pass to each other. I mean, technically nobody passes to a cow falls into the latter category. It's just that it's easier to just say nobody passes to a cow. That's like the main case. Now, isolated group of cows that only pass to each other, as we've shown, that cannot be more than 2 cows. A goes to B and B goes to A. That's very possible. However, A goes to, oh yeah, isolated. Isolated means that no one else outside the group passes to them either. But anyway, so we've shown that A, B, C, like A passes to B, B passes to C, then suddenly in this group, no one's passing to A, so it's going to be a nobody passes to a cow case. So it's that type of thing. So basically just go through it and you see that an isolated group of cows that only pass to each other must have either size 1 or 2. Size 1 is just nobody passes to a cow, or size 2 is just a pair that no one else passes to. Any other questions? Okay, so yeah, I guess that's we're running a bit late, so that's all for today then. Any last questions you can, like, yeah. So any questions? You can just say now. Okay, so of course, like, if you somehow like don't have much programming experience, or like forgot or something like that, again, watch the videos. Like, hopefully you can be able to actually solidly program in your language, like programming language, like Java or something like that, without any problems. That'll be good if you can do that. Okay, so yeah, then that's all for today then. Bye then.